So it's an honor and a privilege to be here this evening. This is my third attempt at giving a Kansa-related talk at SecKC. I think 2.5 years ago, I started working on this open source incident response project called Kansa, just coincidentally, and had planned to, for those of you that don't know, I'm from this area originally, but 4 years ago moved to Seattle to go work for Microsoft to do incident response in cloud service environments. And so being there for several months, and then coming back for summer vacation, I had planned to give this talk at Kansa, and there was some confusion, mix-up, and scheduling happened in a way that I couldn't give it. And then last summer I was going to give this talk, and we came back for summer vacation, and again, same kind of thing, except we decided, let's move back to the Midwest. So now I'm living in the area, it's much easier for me to actually give a presentation here. So the talk, the title there, Kansa Incident Response and Open Source in the Belly of the Best. I'm sure some of you think that's a typo. It's actually just kind of a joke. I don't actually think Microsoft's the best, but there you go. If you came here thinking, oh, this is going to be a talk about open source, let me just get that out of the way real quick. I'm not really going to talk about open source except to say, yeah, I did an open source project while I was working for Microsoft, and maybe they've had an adversarial relationship with open source projects in their past, but they are trying to be more open source friendly. But I would say if you want to do an open source project, you work for some software vendor company, pick something that they don't make money off of, do it on your own time and on your own hardware, and maybe talk to a lawyer. That's all I'm going to say about open source. The rest of this is going to be about incident response. So what is Kansa? It's a modular incident response framework written in PowerShell. Why PowerShell? Well, at the time that I started working on this, I was, like I said, working for Microsoft in cloud service environment. Lots and lots of machines, hundreds of thousands of servers. Some of their cloud service environments have millions of servers. So we needed a scalable solution for doing incident response. Everything, believe it or not, orchestration, automation in those environments is done via PowerShell. PowerShell runs millions of times a day in Microsoft cloud service environments. Everything is set up for Windows remote management and PowerShell. So, if you need to copy a mailbox from data center in Singapore to a data center somewhere else, it's all going to be done over PowerShell. So for me, that was the thing, oh, working for Microsoft now, I better learn PowerShell. This was a great itch that I needed to scratch, and so I wrote this tool. So we'll just do a little brief intro here to this thing. If you're interested in, this is where John Benson gave his talk before, and all, my stuff's going to go sideways, right? Yeah, good times. Well, we won't do live demo. We'll just go through slides, which means I'm going to have to chop up my Franken deck even more. So I had some design goals when I set out to write this thing, and they were, basically I wanted this thing to be modular, not monolithic. So what does that mean? If anybody in here is familiar with like Metasploit, it's very modular, right? There's a whole bunch of different plugins and scripts and those kinds of things. There are, and my first attempt at writing an incident response tool was to just write this giant script that would go out and collect a whole bunch of data points from machines and bring all of that data back, and then we would do analysis on it. The problem with having this giant monolithic script that you run on a whole bunch of machines and you bring back a bunch of data, if you need to run a collection again 30 minutes later, an hour later, a day later, but you only want to pinpoint a tiny piece of data, if you've got some big monolithic script, it's a problem. You want it to be very modular so that you can just select the individual pieces of data that you want to collect. So I've got a screenshot later in the slides of this and how that works. The other thing I wanted to do was I wanted to produce machine analyzable output. If you're having to do incident response across 10,000 machines, 100,000 machines, what have you, it's critical that you be able to analyze the data with, a machine has to be able to analyze it. You can't have analysts sitting there staring at it all day trying to figure out what's going on. So you've got to have machine analyzable output, and the last thing is you want it to be secure. So those were sort of the design goals that I had when I wrote this thing. And I'm not a graphic designer. Here's a terrible sort of architectural diagram of Kansa. So you can imagine there's a core script. In this case, it's called Kansa PS1. And then there's a whole bunch of collector modules. The collector modules are just PowerShell scripts. Those PowerShell scripts do things like they'll pull back netstat data. They'll pull back process data. They'll pull back artifacts from disk. You can take a memory dump. Each one of those collector scripts has a very specific function. They all return data that can be analyzed by a machine. So this is kind of how it works. You build a list of what your targets are, and you put that in a text file, just a bunch of host names, and you modify this file called modules.conf, which I can't show you right now, unfortunately, but I've got a slide later. My live demo's off the charts here. So you configure what you want to collect, and you run the script. It'll go out and pull back a bunch of data from targets and save it to your machine here as the collector output. So in terms of being secure-ish, so the modular piece was done there. In terms of being secure-ish, PowerShell and Windows Remote Management by default uses Kerberos network logins. These are the safest kind of login you can do in a Windows environment. If you're doing a non-delegated Kerberos network login, basically what that means is a tool like Mimikatz can't be used to harvest those credentials. So you can safely do these logins all day long, all across your data center to thousands of machines, and a tool like Mimikatz is not going to be useful for harvesting those credentials. So that was the secure-ish. And the reason I said secure-ish is because there's a lot of things Kansa doesn't do that other forensic tools might do, like, oh, they hash the evidence. So when they collect the evidence, they generate an MD5 hash of the evidence, and that's stored along with it. And then you can say, during the course of your investigation, the evidence hasn't been tampered with because you've got an MD5 hash that was created at the time of collection. Kansa doesn't do that. If you're working cases that may go to court, maybe you want to prosecute somebody, those are the kinds of things you probably want in your tool. So that's why I say it's secure-ish, because there are things that it probably should do that it doesn't. It does run across hosts in parallel. Obviously, you need that if you're trying to scale up. For Windows Remote Management PowerShell, the parallelism by default is 32 hosts. So when you kick off a job, you want it to run across 10,000 machines, it's going to run across 32 hosts at a time by default. That is completely configurable. Another nice thing about this was it's read-write enabled. So when I started working on this 2+ years ago, most of the tools out there, the commercial tools and even open source tools that were available were read-only. And they were read-only for a good reason. Right? These are incident response tools, digital forensics tools. You want to do things forensically sound, right? You don't want to be modifying the machines that you're pulling data from. The problem with that is you've deployed this agent across 100,000 machines or 5,000 machines, whatever your environment size is, and you've got an agent that you can use for pulling data back, but you can't use it for remediation. The nice thing about PowerShell in this instance is because it's read-write enabled, I can effect change on those machines. I can write a script for doing remediation. I can run my investigation for a few weeks. I can figure out this is the way the adversaries owned me, these are what their processes are, or these are the processes they like pivoting in, this is what they inject into, this is what their injected code looks like, and I can write a script that can detect all of those things on the endpoint and kill those processes, set up firewall rules to block their C2, all because I have the capability of effecting change on those boxes. With a lot of the commercial tools, at least at the time that I started working on this, you could not effect change on the remote host. The tools were read-only. Happily, I guess, since then, almost all of the commercial tools now offer some capability to do remediation. So they've all seen the light. That being forensically sound is important, but being able to remediate is equally important. So there is sort of the elephant in the room when you're talking about doing incident response with PowerShell, and that is, doesn't this thing rely on the Windows API? And if I have malware on a box that hooks the API, can't malware hide itself. If you're just running netstat on the machine, can't malware hook the Windows API for netstat and hide its network connections. If you're doing a directory listing, can't malware hook those APIs and prevent itself from being seen? And the answer is yes, right? You've got rootkits that are out there that they do these kinds of things. It's very common. But you're not strictly limited to Windows API calls. There is a Kansa collector that uses recall. Anybody familiar with recall? Anybody using it? Anybody familiar with volatility? Volatility users? We've got a few. So recall is Google's fork of volatility. And the benefit of recall over volatility is that you don't have to take a memory image first. So when I was working for Microsoft, it was fairly common for us to have servers with 192 gigs of RAM. And not just like one or two, but like tens of thousands. Tell me, if you've got a box in Singapore and you're sitting in an office in Redmond, Washington, and you're going to do an investigation, have fun pulling back 192 gigs of RAM in a memory dump so that you can run volatility plugins against it on your desktop. Try recall. You can basically interact with live memory and run almost, it gets better every day. The critical volatility plugins are available in recall. I'll say that. So you can see hidden processes and hidden network connections, things like that. So if you haven't checked out recall, definitely check it out. So yes, this issue of the Windows API can be lying to you is important, and I'm not dismissing it, but there are things that you can do with API-based tools to bypass that. You can install kernel mode drivers and bypass APIs all day long, just like the adversary. So what sucks about Kansa? Lots of things. One thing that sucks that's at the top of the list here that is not necessarily a Kansa problem, it's just an incident response problem in general, and that is long tails. So if you're familiar with the long tail concept, lots of one-offs in your environment. You can imagine if you're running a cloud service, say you've got 5 different core services, maybe you've got 50,000 servers. Just for the simple math sake, we'll say you've got 5 groups of 10,000 servers each. They're all providing 5 different services. Ideally, those buckets of 10,000 machines are going to be very homogeneous, so that when you run a process listing or a directory listing on those machines, hopefully you're getting back data that's very, very similar from every machine. Unfortunately, that's not always the case. There's lots of little one-offs that creep in, lots of delicate snowflakes in environments like this. Every one of those one-offs is basically a rabbit hole that you have to chase down. So you might have a script that runs across 10,000 machines, and you might have 150 different versions of that script according to the MD5 hash for the script. That's 150 different scripts that somebody now has to go look at and make sure that there's nothing malicious in any of them. Which is a problem. So long tails suck, and that's not a Kansa thing, that's just IR in general. Having to chase down long tails is a difficult problem. So if you have any control over your build environment, try and make all of your boxes homogeneous. The other thing that sucks is the hub and spoke model. So if you don't know what I'm talking about, think about the bicycle wheel here. With Kansa and almost all of the commercial incident response tools that are out there, they have this hub and spoke model, right? You've got one appliance that sits in your network, and it can have 10,000 machines that send data back to it. If you want to scale up to 100,000 machines, now you've got to have 10 appliances. If you have 1 million machines, now you've got to have 100 appliances. So it's just, the hub and spoke model is broken. This is not really scale. So, and Kansa has this problem, where it's one machine, lots of data points coming back to it. So it doesn't scale up like I would like it to. If you've got fewer than 5,000 machines that you're dealing with, Kansa works fairly well, depending on what you're trying to do. If you're wanting to pull process listing, network dumps, some information from the registry, those kinds of things, Kansa will work great for fewer than 5,000 machines. 5,000 machines is kind of the breaking point. And the solution that we had was just break it up into multiple hubs and have 20 servers running Kansa pulling data from the environment. So unfortunately, I don't have a good solution for that.
Dave.
Yeah.
So when you say 20 servers, what kind of server do you need to handle that hub again?
So we're just using, when I was running this at Microsoft, we were just using the normal server SKU, nothing special, just something that could talk to the machines in the environment. We typically like to throw up a brand new box that we know is hardened, that isn't compromised. And I had some stories to tell around that, but not on the mic. Double hops are also a problem. Anybody familiar with the double hop problem? Crickets. So the double hop problem is I mentioned the Kerberos non-delegated authentication, right? So it's non-delegated authentication. It means I can log in from box A to box B, and my credentials are not stored on this box. With delegated credentials, I can log in from box A to box B, and I can have some process on box B that can write data out to box C. That is a second hop. So I'm hopping from one box to another to another. That's a double hop there. You cannot do double hops with non-delegated authentication. So there are instances you can imagine where I'm running scripts from box A against a whole bunch of boxes, and I want all of those boxes to write their data out to some other data store. The only way you can do that in a Windows environment is by delegating that credential, which means that credential is now available for harvesting. So Kansa, initially, because I wanted it to be secure against credential harvesting, that was something you couldn't do. But I was asked to make Kansa work against Azure, and there are a lot of customers who have hosts in Azure that are not domain joined. And obviously, if you have non-domain joined machines, you can't do Kerberos authentication. So Kansa now does allow for double hops. So watch out for that if you're using it to log into machines that are not domain joined. You will have a harvestable credential there. And again, API may be a lie. I think I've already addressed that issue. So look, the interesting portion of this, since I don't have a live demo, let's look at some case studies. So after I wrote this thing, we started using it in Microsoft, in cloud services, and we had some success with it early on. And for those of you that don't know, I used to be a SANS instructor, and so I had an opportunity to present at the SANS Digital Forensics Incident Response Summit, and this was the title slide I put together. This was about 3 months after I wrote this tool and went there to talk about it. And at the time, I was filled with unbridled optimism because I had been using it and we were having success. And so I wrote this, why hunt when you can SANE, large-scale hunting and analysis. And then I spent the next 3 years working at Microsoft with this tool, and I think if I was to do this slide again, it would have to be something like this. Scale is very complicated. It's just, depending on what you're trying to do, I mean, go back to the issue of pulling down 192 gig memory dump off a machine in Singapore. Good luck with that on a single server, let alone 5,000 servers or what have you. So the more honest view of this is, yeah, scale is complicated. A lot of it depends on what you're trying to do. Nevertheless, I gave this talk at SANS, and all of the slides that you're about to see were approved by Microsoft Legal for release, and they're all from internal red team, blue team engagements at Microsoft. So none of this is actual compromise, unless you consider it to be, compromised by a Microsoft employee is actual compromise. So when I started there, they had a team of pen testers, and they decided, let's test the blue team. Let's test incident response as a process and as a capability. So let's stop doing pen tests and let's start doing red teaming. So we're going to take this team of pen testers and we're going to let them break into production environments, and we're going to let them set up customer accounts and steal their own customer data and take over production environments, or at least try. So that was the game at Microsoft for like the 4 years I was there, and when I left, they, like a month or two before I left, they decided enough of this game, because it's super stressful for the blue team. The blue team has a day job where they have to actually fight real adversaries, and then on top of that, now you've got to deal with the red team. And because of the way you do red team, blue team, you don't know if you're dealing with the red team or if you're dealing with, APT. Somebody in your management chain knows, but you may not know. So that makes life interesting and difficult. I do think it was valuable. It definitely improved security in the organization. And our red team, those guys were doing things that we weren't hearing about other adversaries doing for like 6 months. We kept having meetings with big incident response companies to review their products, and they would come in and we would ask them, are you seeing adversaries use PowerShell at all? And they're like, no, adversaries never use PowerShell. And our guys are using PowerShells for everything. And when you have PowerShell running 1 million times a day, trying to find the 1,000 PowerShell processes that are malicious becomes very, very difficult. And then, eventually we would start meeting with these IR consultants. So here's another example. So this is data that was also collected with Kansa. I hope you guys can see this one a little better. This is WMyEvent Consumer data. You can guess by the file name. So the weird strings here at the beginning in all caps, so those are made up host names. So we collected WMyEvent Consumers from every host in the environment, looking for backdoors that use WMI. And this was a technique that was relatively unknown. I don't know where one of the red team guys found out about it at the time, but it was something that just wasn't very common. Auto runs from sysinternals at the time didn't collect WMyEvent Consumers. So if you're not familiar with WMyEvent Consumers, this is a Windows management instrumentation. It's a property or a feature of Windows that you can use for doing management of your Windows machines. One of the things it can do is create an event filter that just listens for an event to happen on the machine. And I'm not talking about something that's getting rent into an event log. I'm talking very low level Windows events. And you can do things like, in this particular case, the way this event consumer worked, it was a filter that said, is today Tuesday? Is it 1 o'clock in the afternoon? And is the day of the week, is it an even numbered day? So if it was Tuesday the 12th at 1 o'clock in the afternoon, this filter would catch that and kick off, run a script basically that would check out to command and control. So how did we find this? So we just wrote a collector for this because we read about WMyEvent Consumers and we knew it was a persistence mechanism. And we were the first tool that I know of that would allow you to collect this data. So this was a nice thing that Kansa did, and within a few months, Mark Rusinovich added it to auto runs because we asked him to. So now this is in auto runs, which is a big plus. So basically, it just dumps the contents of the WMyEvent Consumers to an XML file. And anybody care to guess which one of these has the malicious code in it?
First one.
It's the first one, right? So all we did was dump out these files and sort by file size, and you can see the first one is almost 4 times the size of the next largest one. And that turns out to be the one that was malicious in this case. So this is a slide where, interesting thing about, cloud service environments are going to be talking out to IP addresses outside of your environment as a matter of course, right? They're serving up cloud content or whatever service it is. So they're going to have network connections to hosts outside of your environment. That's just normal. So we gather netstat data from thousands and thousands of hosts, and then we stack rank that data. But before we stack rank it, we build a whitelist of internal IP addresses. And the easiest way to build a whitelist of internal IP addresses is to run netstat on every machine in your environment and take the IP addresses that are in the local address field and unique them and put them in a whitelist. And then you can run the query again and say, show me everything where a foreign address is not in this whitelist. And those are all connections to hosts outside of your environment. So that's what we did here. We ran netstat across 5,000 machines and then went to look for the outliers. And the ones that are interesting here are not the W3WP, that's the Windows web server worker process. Not interesting. It's a cloud service. Those processes are going to be talking to hosts outside my environment. Doesn't mean they're not malicious. Some of these might be, I don't know. But the ones that were interesting here is PowerShell. Like I said, PowerShell runs millions of times a day. That's true, but it's almost all intra-data center. It's a machine in the data center to another machine in the data center. It's very rare that you would have machines in the data center talking on PowerShell to hosts outside the data center. So these were very interesting. And this is just stack ranking the data. So you can see there's 10 here. There's 10 different entries for PowerShell communicating out. And the line that says 3, if you can see the 3, it's the one in the middle of the PowerShell collection. That's actually an IPv6 address that we just failed to filter out because we weren't counting on IPv6 addresses being in there. And that IPv6 address range belongs to Microsoft, so those are not interesting. So we wanted to pivot from this data and figure out what these PowerShell processes are, what hosts they're on. And so to do that, we just wrote and all of this analysis is running on a desktop machine. Nothing special, 16 gigs of RAM, not like some big cloud compute thing. And you can see it processed 911,000 rows of data in 3.97 seconds. That's pretty good, I think. I'm not a perf expert, but I was pretty happy with it. And this is just using log parser to query over 5,000 files that contain netstat data. So we want to pivot from this and dive into those PowerShell processes and see what machines they're on and find out more details. So we just wrote a simple log parser query. So if you're familiar with PowerShell at all, this is basically just an @ string that we're building. So we're populating this LP query variable, and we're just building out a query, and all this query is doing is saying, give me the foreign address, the connection process ID, and the computer name, where the process is PowerShell, and the foreign address is in those two ranges that are on the previous slide that are heavily redacted. So we run this query, and in 1.5 seconds, you get back, hey, there's 3 hosts that match this. They've got PowerShell processes that are communicating with the IP ranges that you asked for, and here are the process IDs. So at this point, you've got a process ID. We've already collected process data. When we ran Kansa against these 5,000 machines, we collected netstat data, process data, various artifacts from disk and registry. And so we have all of this data already, so we can pivot from this into the process data. So I take that process ID, in this case we'll take the last one there, the 12208, and we go pull the details for that process. We have the machine name on the previous slide, so it's this AC2COFF business. So basically I take the process data from that machine that I've already collected, and it's stored in an XML file that was created by Kansa, and we just reserialize that data into this variable $data. And then, so $data at this point is populated, and the next line there where it says $data, and I'm piping it out to a where filter in PowerShell, saying, show me everything in $data where the process ID is 12208, and give me the creation date, the parent process ID, and the command line. So what I get back is obviously the creation date for this process. So, hey, it's April 14th of 2014 when this happened. The parent process ID, those things are somewhat interesting, I guess. But what's really interesting here, remember, I'm just chasing down leads at this point. I don't know that this is actually malicious. But at this point, when I see the PowerShell process that's running, pretty sure at this point this is malicious. So I've got a PowerShell exe, and it has these command line arguments passed to it, execution policy bypass, which basically just says, if there's an execution policy set on this machine that is restrictive, just ignore it. And that is a feature of PowerShell. Jeffrey Snover, the chief architect for PowerShell, will tell you execution policy is not a security boundary. It's basically there to keep you from shooting yourself in the foot and doing something stupid. So don't think you can go set security or execution policy on your machines for PowerShell and protect yourself. You cannot. It's easily bypassed, as you can see here. They set the Windows style to hidden. They didn't want this thing popping up on somebody's desktop, and make it non-interactive, and then run this encoded command. So the encoded command here is just base64 encoded PowerShell script. And in this case, it is a malicious script that just says, hey, every 5 minutes or whatever time interval they set, go out and check in with command and control and see if there's any tasks for me to do. So at this point, we knew this thing was malicious. We've got the parent process ID here, so we could do a little more investigation on what spawned this thing. So we did the same thing we did before, except instead of looking for the 12208 process, we're looking for the 1332 process, so that's the parent process ID from this slide. And in this case, it turns out to be spools V, which is very odd. Spools V should not be spawning PowerShell processes. So at this point, we know that not only do they have malicious PowerShell running in the environment, they have the ability to pretty much inject into any process they want and take over any process that runs legitimately in the service and have it be a backdoor also, which complicates matters for us, obviously. So, what do you do next at this point? Well, for us, we would do something like, there's a collector in Kansa called get proc dump. There's also get recall. Recall, unfortunately, pushes like a 17 meg zip file to the remote host, which is, in the column of negatives for Kansa, that's kind of a bad thing. Get proc dump just uses the sysinternals proc dump tool, and you can dump any arbitrary process and pull that memory back and then run your normal forensic analysis tools against it. I mentioned earlier, this is a read-write tool, so I've got the capability to remediate and execute change on the machines. So once you've run your investigation, maybe you investigate for a month, maybe you investigate for a week, however long it takes for the given environment, you can build a remediation script based on everything that you found out during your investigation. We know their processes have these characteristics, they have these byte strings in them, or they're communicating with these hosts. We know these are their C2 IPs. So you build a remediation script that you can then run across all the machines in the environment that will examine processes, look at process memory, look for connections out to known C2, and clean those things up. Obviously, in an ideal world, you just wipe the box and reinstall the OS. But when you're running a cloud service, going in and selling to management the concept of, we have to take the service down. I know it's generating $1 billion in revenue, but we're gonna have to take it offline for a month. That is basically a non-starter for most online services. So you need some capability for remediating short of just bringing the service down. So what we did was we wrote a script that would look for malicious things and basically execute remediation via various means. We kill processes, reboot boxes, set up SRP whitelists, put firewall rules in place that block C2, whatever we could do to try to kick the adversary out of the environment. And this is a game of, and any of the big service firms that do incident response will tell you this, remediation is usually not a one-shot deal. It's, you try your best the first time, and then you keep monitoring the environment to see if the adversary returns or to see what you missed, and that monitoring may take days or weeks. The adversary, if they want you, they're gonna come back. They're gonna try something else. We know from a lot of the reports that are out there that the Chinese have multiple teams that they will send after the same target that are from totally different organizations. So it can be difficult to execute remediation successfully, but in this case, we were very successful. So we wrote this remediation script, and what you see here, the details are not important, but this is the console that the red team wrote for managing their botnet. So they've got a really nice GUI that they can use to keep track of their botnet and to bring up new servers and to pivot into other machines and harvest credentials and all of this. So this is their console. And I'm so glad, this is like my favorite moment at Microsoft during my time there. One of the red team members was sitting in a meeting with the red team and was looking at the console for this particular environment. The top of the screen here, every one of those lines is a host in the environment that they own. Those are all hosts calling home to their C2 in Azure. And normally, if those lines are gray, those bots are healthy. If those lines turn this ugly Texas burnt orange color, it means that those bots are going offline or something bad has happened. And so Justin Hendricks, who's actually from this area, I don't know if any of you know him, he was one of he was the red team guy on point for this. And he's sitting in this meeting and everything starts turning orange. And I guess he just sat there going, oh shit, oh shit, oh shit, because he didn't know if he had tipped over the environment, through something bad happening. And so all these boxes were rebooting or just going offline or failing or what have you. But I'm happy to say it was because of our remediation script. We very nearly kicked them out of the environment, which was awesome. This one box here that shows up as a gray line, there was something hosed about the Windows Remote Management Service on that machine, and so our remediation script didn't execute, but their stuff kept running, so they still had a foothold in the environment, unfortunately, but we got very, very close. So that was pretty fun. So as I mentioned, this is an open source project. If any of you are interested in checking it out, this is where you can get it. Go to GitHub /Dave Hull /KANSA. You can't have Kansa without the NSA. It's there. I'm sorry I planned the live demo, but for whatever reason my monitor doesn't want to switch over to my live environment. I am no longer actively developing on this tool, unfortunately. There are like 7 forks of it and I don't know, 150 followers of it on GitHub. So there are people that are still actively contributing to it. I'm working on a commercial solution in the same space that actually scales very well, way beyond what this thing can do. So I'm not actively contributing to it because it violates one of my rules about contributing to open source tools. That is, don't contribute to an open source tool that conflicts with the way your company makes money. But if any of you want to pick up the slack and take this on, it's pretty easy to contribute to.
Is it in Python?
Yes, it is Python. So here, since I can't do the live demo, here's a screenshot of this thing executing. This is what it looks like when you run it. So you can see the command line there at the top, Kansa PS1. You give it a target list, and this should be some file with just one host name per line. The push bin argument in this case just tells Kansa, hey, I want some third-party binary to run. In this case, it's probably auto runs. So in this case, there's 2 third-party binaries that are going to run. One is handle, which is another sysinternals tool that will dump handles out of processes. So you can get things like mutexes, which are pretty useful for finding bad things. And auto runs is the other one. So pushbin just says, I need you to copy these binaries to the remote host when you run. So that's what pushbin does. If you run this without the target list argument, if you're in a big environment, I wouldn't advise it. If you're in a poorly managed big environment, it's a nightmare. Because what it will do is it'll go query Active Directory for the names of all the machines in your environment and then try and run against all of them. And a lot of people have cruft and dead machines in their Active Directory, and so you'll have all kinds of problems. So definitely build a target list if you can. The next thing it does is it looks at this modules.conf file for all the modules you want to run. And the modules here, you can see the jobs at the bottom. It's going to grab prefetch files. It's going to run netstat on all the machines. It's going to pull DNS cache, ARP tables, process information several different ways, and handle information and information about services and service failure modes, which is another auto start extension point that autoruns doesn't collect. You can configure any Windows service if it fails. You can set up a restart mode for that service, and you can have that restart mode run any arbitrary command or script. So this is a little known auto start extension point that autoruns doesn't collect. I've been asking Mark Rusinovich to add it to autoruns, but it's not there. Kansa will collect it for you. So that's what it looks like when you run it. The directory structure, where the output goes. So this is, again, I would have shown this live, but live demos, this is being prepared for your live demo failure, right? So this is the directory structure. You've got this Kansa PS1 script. That's the core of it. The output directories here, these time-stamped output directories, that means I've run this thing 3 different times. Every time you run it, you get a new output directory created with a timestamp on it. The modules directory has all of the various modules in it. I'll show you some of these in a second. The analysis directory has a bunch of scripts in it for doing analysis. So it's not just about collecting the data, there are also tools in here for analyzing the data. And for the most part, they're just stack ranking scripts. And I think at one point in time, there were like 30 different stack ranking scripts, and it was getting out of hand. So I just wrote one stack ranking script that would stack rank anything. So they've pretty much all been made obsolete by a single script at this point. So this is diving down into one of those output directories. For every collector that you ran, you get a directory with data in it related to that specific collection. So if you dive down one more level, this is looking at the netstat output. So for all the machines I ran this against, I get the data for that particular collector. The collectors are super simple. So this is one of the collectors. This is a collector script. It basically just runs a PowerShell command, and that's it. the Kansa, the core script, the big script that is 1,000 lines long or whatever it is these days, I forget, actually does all the heavy lifting of handling that data and the output for it. So here's an example of some of the analysis scripts. And like I said, you can see all of these in stack because they're all doing frequency analysis, and almost all of these have been made obsolete by a single script now. So that's pretty much it. I've got other slides in here, but I'm not going to go into them because, like I said, this is kind of a Franken deck, just in case the demo did go sideways, which it did. So good example of being prepared for that there. So any questions or feedback or what have you? Yeah.
Yeah. Have you seen this used offensively?
So the question is, have I seen this used offensively? I have not seen it used offensively, but there's no reason why it couldn't be. I mean, PowerShell and Windows Remote Management is a great tool for red teamers. So if you're doing penetration testing, if you don't like incident response because it's too hard, which it's way harder than you red teamers. If you don't like it, you can use this for malicious purposes. You should be checking out PowerShell and Windows Remote Management. There's a lot of great tools out there for it. You have a question over here?
Okay. Question is that you have a script here that goes out and grabs a whole lot of information, and then you have some baked-in tools for analyzing it. Have you tried pulling it into a NoSQL database type system, which already has a lot of those data things built into it?
Oddly enough, that was like the last thing I was working on at Microsoft. And so back to the open source piece of this, I wrote all of this, almost all of this was written on my own time, on my own hardware, on after hours, and I knew it didn't compete with Microsoft. And then we started using it during the day job, and obviously we would find bugs, and we wanted to add new features, and so some of that stuff started slipping in during the daytime, and I got the hand slap from Microsoft Legal for that. And that is one of the things that we did before I left, was make this thing Azure capable, so that you could use Azure for the back end, and you could shove everything into Azure's equivalent of a NoSQL database. But since that was done on Microsoft's dime, that'll probably never see the light of day. So. Yes, Bill.
So, what do you mean, yes, Bill?
Yes, Manager Bill.
Director.
Oh, Director.
So if I want to deploy this in a 60,000 node environment, what do I need to get started?
So the question is, how do you deploy this in a 60,000 node environment? Well, you need to have Windows Remote Management configured on all of your endpoints, obviously. Which it's a relatively simple thing. You got to run like winrm quick config is the command line tool to do it. And you can turn it on. I think you can turn it on by GPO. So you should be able to turn this on by GPO. You can lock it down. You can require certificate-based authentication if you want. Microsoft's not a problem, right? For us, it was never an issue. This was already there before I ever even started on it. Windows Remote Management was already turned on. People were already using it to administer everything via PowerShell. So for me, that was not an issue. But it's super easy to enable, and I believe you can do it through GPO.
Is that documented in the Kansa documentation, or
is it documented in Kansa's documentation? No.
What's the documentation?
There is Kansa documentation. If you do, I wish I could bring up my other machine here. Let me take a quick stab at this.
Try harder.
Yes, I will try harder. Oh, look at this. All I had to do was go out of my.
Computers are hard.
Hold on a second.
Here.
That's literally the worst drop the mic ever did.
What's your password?
Don't you drop that mic.
So for good PowerShell tools, they should be basically self-documenting, right? You can write help. So for those of you that missed the command, just download the tool and do get help-full Kansa PS1 and pipe it to more, and you'll get a pretty verbose help listing for how to use it with use cases and explanations of all the command line parameters and all of that. It doesn't talk about setting up WinRM, unfortunately. You have to go read some MSDN page for that.
Yeah, no, I heard you.
Any other questions? Yeah.
Would this be useful for a single host?
So the question is, would this be useful for a single host? In my opinion, no. The sweet spot for this, in my opinion, is running across a bunch of machines and looking for the anomalies to build leads for a case. The single machine case, if you know you've got a machine that's compromised and you just want to pull back specific things from that machine, then yeah, it's a great use case for that. But if you're just like, oh, I want to go see if this handful of machines, these 2 or 3 machines, are they owned? I'm going to go run something against them like this. I don't think it's as useful in that scenario because the primary use case is pulling data back from a whole bunch of machines and then looking for the odd things that are unusual. So it really shines in an environment where you've got machines that are largely homogeneous with the same processes, the same directory structures, the same network connections. That's really the sweet spot for this kind of a tool. Any other questions? Cool. Thank you all.
We have free, so tell us about the new company.
Well, Trent says I should tell you about the new company I'm working for. I didn't want to turn this into a commercial for some vendor. So,
Good job, Dave.
Yeah.
Thank you.
If you're interested, I am working for a company called Tanium. They're kind of a startup. They're in this space, but they can scale to hundreds of thousands of machines. So if you want to find out about that, come see me after. Thanks.
All right, Dave.